This is the Chapter 3 problem set number 4, starting with 3-90. So 3-90A asks you to solve for y with 2y minus 3 in parentheses equals 4. So I have a choice here. I can either distribute the 2 or I can divide by the 2. I'm going to divide by the 2 because 4 is even and I know that's going to be pretty. So then I get y minus 3 equals 2. I'll add 3 and y equals 5. For b, we're going to solve for x. We get 2x minus 6y equals 12. I can see there's two variables here, so I'm going to end up still with an equation probably. So x alone, that means I'm going to get rid of the 6y. 2x equals 6y plus 12. Now we'll divide everything by 2, and x equals 3y plus 6, or x equals 6 plus 3y. Either one works. Okay, for c, we are solving for y. We have 6x plus y equals 2y plus 8. I'm going to subtract y from both sides and subtract 8 from both sides. So I get 6x minus 8 equals 2y minus y is y. So y equals 6x minus 8. Finally, for d, we have 3 times 2x plus 4 equals 2 plus 6x plus 10, and we were solving for x. So I'm going to do distributive property over here, because when I look over there, the 10 and the 2 aren't going to divide by 3 nicely, right? So I may as well just distribute. So 6x plus 12 equals 10 plus 2 is 12 plus 6x. This is looking very similar on both sides, isn't it? Minus 12 minus 12, and I'll take away a 6x. So now I have negative 3x equals 0, divide by negative 3, and I get x equals 0. Just kidding. Did you catch my mistake? I did 2 times 3x, and I got 3x instead of 6x, which would make that be 0x equals 0. In other words, 0 equals 0, which means any number, or all solutions, or all numbers, something like that. Sorry about that. All right, for 105A, we're solving for c in the very famous equation E equals mc squared. I need to get c alone, so I'm going to get rid of that m first by dividing by m. So E divided by m equals c squared. Now I'm going to take a square root of both sides, like so, and that gives me the square root of E divided by m equals c. You can take the square root of both sides because anything like squaring is the opposite of square rooting. All right, b. We have solve for m when it's a equals f divided by m. So here, this is the one time where if I try and get rid of the f, that's not really going to help me very much. So I actually need to start by multiplying both sides by m, because that'll allow me to get the m up from out in the denominator of the fraction. So that gives me m times a equals f, and then I can divide both sides by a. So m equals f divided by a. And that's because these two would cancel like that. All right, on c. Now we are solving for x. We have negative 6 equals negative 6 times the quantity 3x minus 8. And I have a choice here. I can either distribute that 6 or I can divide. This actually would divide pretty nicely, so I think I'm going to do that. I'm going to divide by negative 6 on both sides. So that gives me a positive 1 equals 3x minus 8. If you did it the other way, it would still work. And then I'm going to add 8. So I get 9 equals 3x. I'm going to divide by 3 and get x equals 3, because 9 divided by 3 is 3. On D, we're solving for y in the equation 3x plus 6y equals 24. I want y alone, so I'll start by subtracting the 3x. So 6y equals negative 3x plus 24. I'm going to divide by 6 all across the board and get y equals negative 1/2 x plus 4. Because 3/6 is the same as 1/2. Then for, that was D, so we're now on E. We're solving for x. 2 minus 3 times, in parentheses, 2x minus 1 equals 17. I'm going to distribute to both sides. So 2 minus 6x plus 3 equals 17. The 2 and the 3 would make a 5, so negative 6x plus 5 equals 17. I'll subtract 5. Negative 6x equals 12. Divide by negative 6, and x equals negative 2. Oops, sorry. And we have f. Solving for y this time. The absolute value of 3 minus 5y equals 3. So I'm going to split this. 3 minus 5y equals 3, and 3 minus 5y equals negative 3. So solve them both. Minus 3, negative 5y equals 0. Divide by negative 5, and y equals 0. Is the other one just going to be 0 too? Let's figure out. Minus 3, oh no it's not, because a negative and then minus a positive takes me further into negative, so that's negative 6. Divide by negative 5, and y equals 6/5, which I think would be 1.2. Alright, so I've got two answers there, 0 or 6/5. Alright, on G, we're solving for x. We have y equals negative 3x plus 4. So I want to get the x alone. So I'm going to start by subtracting 4 from both sides. Y minus 4 equals negative 3x. Now I'll divide by negative 3. And let's see, negative 1/3 y plus 4/3 equals x. Something like that. You also could have left that as x equals y minus 4 divided by negative 3. That would also be accurate. Either one is fine. Let's see, GH is solve for x. X times 2x minus 1 equals 2x squared plus 5x minus 12. That will be 2x squared minus x equals 2x squared plus 5x minus 12, minus 2x squared from both sides. That gives me negative x equals 5x minus 12, so I'll subtract 5x from both sides. So that gives me negative 6x equals negative 12. Divide by negative 6, and you get x equals a positive 2. Now we're going to solve on I, we're going to solve for w. We have 2, then in parentheses, v minus 3 equals 1 minus w plus 4. So 2v minus 6 equals 1 minus w minus 4. We're trying to get w alone, so I just need to take away the 1 and add the 4. Maybe I should combine those first. Let's combine those first. That's a nice way to do it. 1 minus 4 is negative 3 minus w equals 2v minus 6. So then I'll add 3 to both sides. 2v minus 3 equals negative w. Uh-oh, what do I do with that negative w? I'm going to divide everything by negative 1. That's what I'm going to do with that negative w. So that gives me negative 2v plus 3 equals w. And j. We're going to solve for x. It's going to be 4x times, in parentheses, x plus 1 equals, in parentheses, 2x minus 3 times 2x plus 5. You get to do a generic rectangle. Remember those? So 4x times x is 4x squared plus 4x. That's this first part here. And then over here, we have to generic rectangle it. So I'm going to do my generic rectangle over here, just to not mess up my space. So 2x minus 3, 2x plus 5. 2x times 2x is 4x squared minus 6x plus 10x minus 15. 10x minus 6x equals 4x. So 4x squared minus 4x minus 15. And I'll take away 4x squared from both sides. So now I have 4x equals negative 4x. No, that's not a negative, that's a plus 4x. It's positive 10 minus 6. Okay, equals plus 4x minus 15. I'll take away 4x, and I get 0 equals negative 15, which tells me this is no solution. Because we ended with a false statement. All right, 109, we need to find the equation of a line with a slope, that would be m, equaling 1/5, passing through a point, xy, of 10, 9. So I'm going to do this in y equals mx plus v format, although you do know a couple other formats. You could do this in point slope if you wanted, but I'm going to do this way. So I'm going to plug in 1/5 for m, so y equals 1/5 x plus b. I know an x and a y, I do not know a b, so I'm going to plug in my point for x and y. So 9 goes in the place of y, equals 1/5 times 10 plus b, so 9 equals 1/5 of 10 would be 2, plus b. I'll subtract 2 from both sides, and I get 7 equals b. So my equation is y equals 1/5 x plus 7. And finally, we were supposed to do 112. So on these ones, we are simplifying using the laws of exponents. A was 3x squared y times 5x. So rewrite it without the parentheses and with the little multiplication dots. I find that helps me keep things straight. So 3 times x squared times y times 5 times x. Just change the way it looks, even though we haven't really done anything here. All right, so then I'm going to combine the like stuff. So 3 times 5 gives me 15, and x squared times x would give me x cubed, and then the y stands alone. 15x cubed y, or 15y x cubed if you wanted to put it in that order. Then on b, we have x squared y cubed times x to the negative 2, y to the negative 2. Once again, I'm going to do the same thing. X squared times y cubed times x to the negative 2 times y to the negative 2. Then I'm going to combine my similar stuff. So x squared times x to the negative 2. Remember, that's like x squared plus negative 2, right? Or x to the 2 plus negative 2, which would be x to the 0. And then y cubed y to the negative 2. 3 plus negative 2 would be y to the 1. Well, x to the 0 is just 1, and y to the 1 is just y. So this is the same as just a single y. On C, we have x cubed over x to the negative 2, and the rule here is we subtract. So we do 3 minus negative 2. 3 minus negative 2, right? Because whenever we are dividing our exponents, then we subtract, or whenever we're dividing the bases, then we subtract the exponents. So that would be x to the 5th. If you don't believe me on that, the other way to do this would be to say that this is x to the 3rd times 1 over x to the negative 2, and to know that that is the same as x squared. So x cubed times x squared would be x to the 5th. All right, then on D, we have 2x to the negative 1 to the 3rd. So here, remember that this is 2 times x to the negative 1, so that cube applies to them separately, and that negative 1 does not apply to the 2. So 2 cubed is 8, and then negative 1 times 3 would be negative 3. That would be one possible answer. Oh, but they say only positive exponents, so that means that we need to, remember that that's times, so that becomes 8 over x to the 3rd, or 8 times 1 over x to the 3rd. Either one of those is fine. But the 8 cannot end up in the denominator because that negative 1 did not apply to the 2. Right? That negative 1 just applied to the x, because order of operations says that the exponent happens before the multiplication.